So this is the C-CDA on FHIR track, also known as the FHIR documents track. I'm Rick Geimer. I work at Lantana Consulting Group. I'm the Chief Innovation Officer there. And a lot of folks know me from HL7. I work in the CDA management group. I'm a member of that. Also FHIR infrastructure. Used to be a co-chair of the structured documents work group. And when I've got any spare time, I'm in the attachments work group for HIPAA attachments. Basically, I work for Lantana Consulting Group. We're a healthcare services company, do a lot of work for CMS, CDC, and also private clients as well, helping them do strategy, converting data, things like that. So today, what we're going to do is we're going to start with an overview of clinical documents, or electronic clinical documents, I should say. We're then going to show how they are represented in FHIR. We'll talk about the FHIR document paradigm and how it works. Then we'll dive into the C-CDA on FHIR specification, which is a new U.S. realm implementation guide that's meant to basically represent the C-CDA or consolidated CDA use case using FHIR resources. And we'll also talk a bit about the U.S. core project since C-CDA on FHIR is heavily dependent on it. We'll wrap up by talking about converting, managing, and validating FHIR documents, and then we'll talk a little bit about future work that's going on. So clinical documents, you can find them all over your medical record. You can get old paper-based documents that maybe you scanned into PDF and such. You can have consolidated CDA or C-CDA documents that you can bring up and display using various style sheets. You can actually represent things like DICOM, diagnostic structured reports as clinical documents. And you can bring them up and browse them on your slightly old iPhones if you wish. My point is that there's clinical documents are all around us. They're used every day. They populate probably the majority of the patient chart. And a lot of people don't really think about them and how they work. So clinical documents have several key characteristics that differentiate them from messages or things like typical RESTful queries and such. The first of them is persistence. Clinical documents are meant to be kept over time. They're meant to persist. They're a permanent part of the patient's record. If you think about the paper world, when clinicians, sometimes they still do, but carry around those old manila folders with all those documents in them that they've written up and signed, they can't just throw those out at the end of the day. Okay, they're a permanent part of the patient record. Often there's legal retention requirements around there, something like 7 years and such. Just because you take those and move those into the electronic realm, those requirements don't go away. So when you start thinking about processing clinical documents, remember that you need to find a way to store them as well. They shouldn't just be generated and just thrown out. If something's going to be persistent, then you also need someone who takes responsibility for keeping a copy of that. That's called the steward or custodian of that document. It's the organization that's maintained with its care. Probably the most important one on this list, characteristic, is the potential for authentication. Clinical documents are meant to be signed. In other words, they're things that clinicians will attach their signature. They'll attest to the content that's within them. So if you see something that carries a clinician's signature on it, be it a real wet signature or an electronic signature of some kind, there's a good indication that it might be a document and not something ephemeral like a message. Context. So a clinical document establishes its default context for its content. In the old, I said the sort of current HL7 version 3 based CDA, that's called the header of a CDA document. It has things like what kind of document is it? Is it a history and physical or a procedure note or something like that? It'll say who the patient is, who the author of the document is, what time it was created, all that type of stuff sets context so that you can get an idea of what's coming next. Sort of paired with that is that concept of wholeness. So you wouldn't use a clinical document just to exchange somebody's blood pressure and nothing else. Rather, you would use that to exchange maybe a history and physical that includes their full vital signs and a bunch of other information as well. So they tell a whole story, usually about an encounter or summary of care over a period of time. And lastly is human readability. Documents are meant to be read by people. Certainly there's a ton of coded information in there when you move into the electronic realm so that machines can also process them. But at the end of the day, every clinical document has a human readability as a sort of a fallback. And this becomes important when you're talking about exchanging documents among systems or organizations with different levels of sophistication. Let's say that you've got a very high-end EHR, your organization has spent a lot of money investing in SNOMED and LOINC and can do all these great complex codings, but then you send that document to an organization that is really just a mom and pop shops. Maybe they don't have any of that sophisticated terminology mapping. They wouldn't know what those codes mean, but they could always open it up in a web browser with a style sheet and display it. So human readability is that sort of key level of interoperability, that very base level, which is eyeball interoperability. So to talk about electronic clinical documents, I'm going to give a very brief history on CDA, or Clinical Document Architecture as it's known. So this is a specification for defining electronic clinical documents. It's an ANSI and an ISO standard, and it's the base standard on which many of the implementation guides that are exchanged today, like for meaningful use and such, are based. So if you've done consolidated CDA or quality reporting or any of those types of things, they're based on CDA. So just a quick show of hands, how many folks have worked with CDA or consolidated CDA before? Quite a few. I guess that's why the title of this track was attractive to you. Consolidated CDA is probably the most popular CDA implementation guide that's out there. It contains about a dozen different document types. Its impetus, or the reason why it was created, is because we originally had a whole bunch of single implementation guides, like for a consult note or history and physical and such, and continuity of care document, or C-CD. In fact, and then different organizations went around and customized those implementation guides, so we ended up with like 3 different versions of C-CD floating around, and then one of those organizations, HITSP, just decided to disappear one day. And left no one really in charge of maintaining that. So HL7 took up the charge and worked with other organizations, with HITSP, with IHE, with the Health Story Project, and brought all this back together into one single sort of master implementation guide for primary care. So if we've got C-CDA and people are exchanging documents with that today, what can be improved? Why change it? So I like to start off with what I call Graham's Law. He doesn't call it that, but Graham Grieve, the father of FHIR, he's got a lot of great sayings. The one of his that I probably like the most is that you can hide complexity or make it worse, but you can't make it go away. CDA and HL7 version 3 in general was a lot more complex than necessary. Things that should have been simple technical problems, like just exchanging a date, became difficult and roadblocks for implementers because, of course, the date format that HL7 chose for version 3 was different from what everybody else uses. Little things like that that cause you to waste, a few hours of developers' time, but then you multiply that by dozens and dozens, and it becomes, it can eat up your budget very quickly. So even though CDA was sort of stable and simpler than the rest of HL7 version 3 and saw more widespread implementation, it inherited much of that complexity. And it never had a viable API component. It was really just a standard for, here's what electronic documents look like in XML. Didn't tell you really how to send it and such. Those were all, there are a bunch of related standards out there, like IHE's XDS specifications, direct messaging, things like that. But those aren't really sort of built in. It was never tightly coupled to the standard. So FHIR, in my opinion, makes simple problems simpler again. All right, so you got to use RESTful APIs that are familiar with folks. You can use XML or JSON. The data types are the right ones finally. So you can just sort of pick stuff up and start going. There's lots of reference implementations out there from day one. So you don't have to waste a lot of time working on those simple things. And you can get to the hard problems quickly, like terminology, which is FHIR does not make easier, by the way. If you're dealing with SNOMED and terminology mapping and RxNorm and all that, you want to get to those hard problems fast because that's where you want to spend your budget on because, again, FHIR won't solve that for you. Another reason why I like FHIR for clinical documents is that many CDAs exchanged today, in my opinion, are just EHR to EHR data dumps. Everyone implemented the consolidated CDA spec according to the meaningful use rules, and they just decided to take everything in their EHR about a patient and dump it out into a C-CD or one of those other document types, and shove it along from one EHR to another. What I hope to see is that if really the goal is to just get all the information that you want about a patient or get just a specific piece of data, instead of having to send everything over the wire back and forth, you can use FHIR queries for that same purpose or something like FHIR bulk data. Much more efficiently than you can use CDA or even FHIR documents. So my hope is in the future we'll get away from those kind of data dump documents. I would be super happy if the C-CD document type just went away completely. I never want to see them again. And we get things like history and physicals, procedure notes, progress notes that are actually clinically relevant. So I hope to see a lot more clinically relevant documents and less of those data dump ones in the future. And I think FHIR can get us there because it's got a better way of managing that sort of bulk data use case. So this is DevDays, we don't really need to talk about this. Everyone knows what FHIR is. I always throw up this Lego analogy slide, mainly because whenever anyone did this in the past, I would hate it. I would look at a standard and they'd make a Lego analogy and I think, oh, really? Is it that easy? But this is the first one where I actually feel, it actually deserves it. So I'm the guy now putting up the Lego analogy slide. Basically resources are blocks. You can assemble them into bigger constructs like documents or bundles, and you can operate on them much like Lego Mindstorms using FHIR APIs. So there are some similars and differences between FHIR and CDA. So some similarities are that they both support profiling for specific use cases. In CDA, we call that templating, not profiling, but it's basically the same thing. You're doing things like making something that's optional, required, or making something that's repeatable, limiting it to a single one, or binding things to specific value sets. Both have human readability as a minimum standard for interoperability. So every FHIR resource can have a text property that is XHTML. And there's validation tooling and profiling tooling available for both. Some key differences though, and this first one is a little bit controversial, some people don't agree with me on it, but FHIR you can pretty much use out of the box. And I put some quotes around that out of the box. What I mean is, a developer can pick up the FHIR specs, some of the FHIR reference implementations, and start doing something meaningful with it right away without creating profiles or even using profiles. It's kind of hard to do that with CDA because it's so generic and so broad, but FHIR has already specific resources like allergy intolerance and such, condition, that CDA never had. They just had the generic observation, and you really had to, if you wanted to express an allergy, create a template on observation that told you how to use it for an allergy use case. FHIR's got a lot of that already baked in. The only thing that's not really baked in many cases are the terminologies that you want, and the base resources make everything pretty much optional. So that's why I say profiling is still recommended, but not necessarily required just to get started in doing something useful. FHIR also encompasses a lot more than documents. You've got discrete resources, you can do messages, you can work with the APIs. So there's a lot more to the FHIR spec than just how do you represent documents in XML. And lastly, implementer tooling is generated with a spec in FHIR. It's very tightly coupled with it, generated during the build process, including that validation tooling and such. So the coupling to everything around that you need to create and use FHIR is much tighter than it ever was in CDA. And CDA, a lot of that came after the fact. So FHIR documents, let's talk a little bit about them. So FHIR documents address the CDA use case for clinical documents. And they're represented basically using a thing called the composition resource. You can think of that as the equivalent of the CDA header plus the human readable narrative all in one resource. It's a single discrete thing that can be signed, attested to. But the cool thing is that composition resource can also point to just about any other resource in the FHIR spec to hold its coded data. And then you would send that, basically wrap that using a bundle resource and send it along from one party to another. Clinical documents in FHIR, or FHIR documents I should say, can be signed and authenticated just like in CDA. And a FHIR document has the same basic obligations. So if you remember those key characteristics like persistence and such, they apply to FHIR documents as well. In fact, one thing to think about when you're dealing with FHIR documents, I mean, a lot of people work on FHIR servers and one day the FHIR server's up, next day it's down. One advantage of using FHIR documents when you bundle them up is you do get a complete package of everything that was that you created about that patient at that point in time. And you can send it from point A to point B. You can store it in a document management system, do whatever you want. In fact, I like to note that clinical documents, regardless of the specification they're created on, often outlive those systems. Okay, so when you start thinking about things like FHIR versioning and such like that, and bringing servers up and down, having a persistent format that's going to stay around for a long time is key. So here's a quick slide on how FHIR documents look in sort of an abstract sense. You've got, let me see if I can get my mouse over here. You've got your composition resource, and this has all the sort of basic metadata about the document, like what kind of document it is, the LOINC code for it, what date it was created, who the author is, and such. You've also got information about who the attester is or who's signing this document. In CDA, we would call that the legal authenticator. Then you've got a series of sections, and those sections can nest, but in practice they usually don't in the US. And those sections can then point to various discrete resources to contain all that coded information. Those sections themselves also contain narrative markup in XHTML. So basically, when you bundle all that together, you get a bundle resource with a series of entries, the first one being the composition resource, which then points to everything else. So the composition resource contains information about the patient, the author, the custodian, or the steward of the document, and all that type of stuff. You can think of it as being sufficient for locating records, for records management, document management, and such. And there's a lot of search properties on the composition resource to help you find documents. So you can search for, for instance, I want, the patient's most recent history and physical. You don't have to do anything custom to do that using FHIR documents. All those search properties that you need for that are already built into the composition resource. So every FHIR server can let you build systems that operate like that very quickly. So sections and narrative in the composition resource. A couple things about it. First of all, the narrative markup is XHTML. Unlike CDA, CDA had its own sort of proprietary markup language for the human readable content. In FHIR, it's just XHTML. So if you've already got a system that maybe is a web-based EHR, or you're used to generating HTML, that knowledge transfers directly into FHIR. So when you're making FHIR documents, you don't have to worry about, the P tag is actually called paragraph or something like that, like you do with CDA. So the narrative contains the attested text of the document. In other words, when the clinician signs a document, it is what you put in, they are signing what you actually put in that text or in that narrative markup. So in other words, they're not signing the SNOMED codes that are, in the observations that you make. They're signing the actual text that you've shown them on screen that they're reading. So one thing to be aware of, make sure you populate when you're creating your FHIR documents, that you populate that narrative section, especially if you're talking about signed documents. So it is also okay for sections to consist only of human readable text. So you don't need to have coded resources in your FHIR documents. There are many use cases for narrative-only documents, but obviously, the ones that folks I think are used to sharing today to qualify for meaningful use do require a large amount of coded data. So that's certainly still there, that's certainly possible, but there are other use cases for things like administrative notes and such, where there's not a lot of value to coding, or potentially where there's just simply no codes exist for what you want to represent. So just something to be aware of. So the way narrative markup or sections look in FHIR is pretty much like this. We've got an example section with the title of allergies and intolerances. We have a LOINC code down below, which actually shows that's the allergy and intolerance section. And that's the exact same LOINC code that would appear in a CDA document with an allergy section. If we scroll down a little bit, we then see text with some XHTML in it. In this case, we've got a bulleted list or unordered list with penicillin-hives. And if you were to take that, take this whole section and bring it up in a web browser, render it with a style sheet, it would look kind of like what we got over here on the on this far side. You'd have allergies and intolerances title, and then penicillin-hives. All right. So a human can look at that and pretty much tell, oh, you give this person penicillin, they get hives as the reaction. But to make this computable, you want to use something, in this case, the allergy intolerance resource. So here we've got the allergy intolerance resource up at the top. We've got the code, which is allergy to penicillin. And then over here, we've actually documented the reaction, which is hives. So this is basically in your composition resource, you'd have this page. Up in the composition resource is the section narrative text. And then right below it, you'd have a reference to the allergy intolerance resource, which is how a computer would process this. Right, so enough about FHIR documents in general. Let's talk about the C-CDA on FHIR specification. So this is a US Realm implementation guide. It is fairly new. It was just published in April of this year. It had been in work for quite a while. Its first ballot was actually in September 2016. It's just a 4-comment ballot just to see if anybody was paying attention or interested. But its real first ballot as a standard for trial use, or STU, was January of 2017. And then we spent the better part of a year trying to get it working. I would say out of that time, probably about 3 months was spent on ballot reconciliation, and then the rest of the time was trying to get the FHIR IG publisher tooling to work. If anybody's done that, it can be quite painful. But we did finally get it out. It is up there now. Basically, its goal is to create FHIR profiles for the consolidated CDA use case. And to do that, we decided we weren't going to reinvent the wheel. We weren't going to create all our own profiles for every template that's in CDA. Rather, there was our what we call sort of a sister project there, the US Core project, which was already going through and creating FHIR profiles for the Common Clinical Data Set, or C-CDS. So we just kind of put a stake in the ground and made an early decision that for any CDA templates for which a closely equivalent could be found in US Core, we were just going to use it. All right, and for anything where there's a CDA template for which there was no profile created with US Core, we weren't going to do it. Rather, what we would do is we would provide guidance on what unprofiled resources could be used. And we pretty much stuck to that. I think we ended up making 1 or 2 additional profiles, but not much. And actually, we haven't heard a lot of complaints so far, because I think US Core actually covers a lot. I know Emma's going to you're going to raise your hand because you've got a couple complaints, I think, but. Right. Yeah. Yeah. Mhm. Correct. I'm not saying we aren't going to go and do that, but to get that sort of first shot across the bow and get a usable specification out there, that's what we did. And we understand there's a lot of things that, for which, again, having a firm profile, US RUM profile would be great. Certainly, as we go further on, I'll talk about the CDA to FHIR mapping project, which is just started last month. We'll be addressing a lot of those during that project. So this is a first STU to get it out there and have it get some trial use going on. And like I said, I understand what we're talking about is, the 80% that US Core represents maybe is not everybody's 80%, but it was a good enough where we knew we can get this out the door without, a major funding. There was actually no funding behind this project. It was all a volunteer effort. Where do you find CCA on FHIR? So if you want to find it, you can go to the FHIR homepage and then scroll down to the very bottom, and you see where it's sort of highlighted in red here, this thing that says implementation guides. So you just click on that first link down below that says published by HL7, FHIR Foundation, et cetera. And you'll find a page will come up and it'll have US Core up there. And I think like the third one down is C-CDA on FHIR. You can also just use these links that I've got up at the top. There is the published specification and the current build. Right now, they are pretty much in sync because this was just published in April and we haven't made any updates since then. But that will be changing probably over the summer, certainly by the fall, as the CDA to FHIR mapping project that I just talked about gets underway. So a little bit about the US Core framework. So as we mentioned, US Core is based on the Common Clinical Data Set, and it contains many of the things that are required and that are exchanged in CDA documents that we see today. Things like problems, allergies, medications, lab results. So all that type of stuff is present. There are a few things that you would expect to be there that aren't, aside from what Emma mentioned. You'd also notice that there's no US Core encounter profile. Well, some of those they're working on, they're adding. Others, they've just said are going to be out of scope for US Core. So there will be stuff that will need to be added. But in some cases, many of those can, again, we haven't found anything that can't be, at least that's in common use in CDA documents today, that can't be at least represented using an unprofiled FHIR resource where there is no US Core one. Yeah, sure. The reason why we didn't do that, this goes back to a little bit of history. The earlier version of the composition resource actually did not have a list of entries in it. What we actually had done for FHIR DSTU2 was we brought in the properties of list into the section element in the composition resource itself. So section has, 0 ... star entries and all the properties of the list resource, so you don't actually need one. You don't need to do that double wrapping where you've got a section that points to a list and then pulls in the meds. You can just include them directly. But there are some people who still want to create lists of lists in some cases, so we don't prohibit that, but just that's kind of the approach that we went. So let me go ahead and quickly drop out of here, and I'll give a brief overview of the spec itself. I actually should have got the lavalier mic for this now, because I'll have to be driving with one hand. I think I can manage though. So here's the FHIR, current published spec, or the STU3. So you can click on here, and you get the FHIR implementation guide registry, and then next you can just go right here and see C-CDA on FHIR. And I'll note all the versions that are out there. The one that you're interested in is the current version, STU1. This first page here just gives a bunch of background information on the spec itself. It talks about using US core as the 80/20 and so on and so forth. But really where you want to go to is the profiles page. So here we've got a series of profiles. The first of them is the US realm header. Now folks who are familiar with consolidated CDA know that there's a US realm header template, which is sort of the base for all these specific document types in consolidated CDA. And we took the same approach with C-CDA on FHIR. So in other words, we created a US realm header profile on the composition resource. It's meant to be an abstract profile, so this one you wouldn't actually implement directly. Rather, it's the base profile for which others are derived. And it does things like create some extensions that we want to use for things like who the data enterer is, the informant, information recipient. These are some properties that are not present in the core composition resource, mainly because composition is a little more generic than the CDA spec. CDA was laser focused on clinical documents, whereas the composition resource can be used for any kind of document. It can be used for catalogs of orderable parts and such. So there are some properties of clinical documents that weren't considered to be part of the 80% for all documents that you could talk about in healthcare. So in those cases, we created some standard extensions for them. So you can go down and see those present. Then we've also done things such as we've bound the subject to a US core patient or a group. We bind the author to the US core practitioner or practitioner role, or also for things like US core patients for patient author documents and such. Also devices, if you wish to have a device author document. Then we go down and make sure that you've got at least one. If you're going to have an attester that is has legal responsibility, that there is one of those present. And then you can also have professional and personal signatures as well. Personal one, for instance, would be for a patient-authored and patient-signed document. Okay, so from there, you can then go down and see the various profiles for the different document types that are present. So in this case, I'm just going to bring up the continuity of care document. And this one here, if we scroll down and look at its differential table, it looks a lot smaller because, as you see here, this is derived from the US realm header, so everything that's in that header applies to this one. So all you're seeing in this differential are the differences between the US realm header and this. In this case, we bound the type to this code from LOINC. That's the code for summarization of episode note. We've required that you have a service event showing the start and end periods over which you're summarizing this patient's care. And then we have a series of sections like allergies, intolerance, medications, and such. In other words, exactly the same sections that you would, with the same requirements or cardinality that you would see in consolidated CDA and the old CDA-based spec. But the difference you'll notice here is that where we talk about the coded entries now, we've got references to other US core profiles, like the US core medication statement, US core condition for the problem section. And you can go down and sort of see that, throughout. So these are, active links, so you can actually go here and click and go directly to the US core spec and see the US core condition and everything that's required on this. Click on its differential and you see that it requires a code that's bound to the problem value set, and subject is a reference to US core patient. So we've tightly integrated these two specifications together, so you can click from one to the other pretty easily. Right, and I think that's about it for this. There are several, again, we've defined some extensions, so if you want to read more about them here, you can. We do have a section descriptions page, so if you want to go in and quickly see, what the encounter section looks like, you can click on it, and you can get the encounter section and see where it's used. So this just provides some good navigation around, especially if you're familiar with CDA and you want to see how and where something's represented using C-CDA on FHIR. All right, so let's go back to the presentation. Make sure I'm doing okay on time. I think I got about 10 or 15 minutes left. All right, so converting from C-CDA to C-CDA on FHIR. First of all, you might want to ask why. If we've got a usable spec out there, why do you want to convert? Well, in my opinion, it's currently, while EHR's FHIR APIs are still kind of maturing, whereas their CDA export is quite mature and quite robust, for me, it's a critical way, it's a way to get to a critical mass of FHIR documents or just raw FHIR content. Yes, I can go to Epic or Cerner and hit their FHIR APIs and get patient, a problem, a few other resources out there. But if I grab one of their C-CDA documents and convert it to FHIR, I can actually get a lot more data today than I can through their FHIR APIs. Now that's changing. I hope it changes faster. But until then, this could be a good way to get a lot of FHIR content. You can also think about FHIR documents as providing continuity with existing practice, but with better syntax and APIs. And one of the big ones, though, that I like is that software developers, a lot of them, when I show them CDA and FHIR, maybe give them training on both, if they don't have an existing CDA infrastructure, they immediately gravitate towards FHIR because it's just simpler, bottom line. So what I found is you can often teach developers how to create FHIR documents much easier than you can to create CDA documents. And then you just need one conversion script. You can train hundreds of developers, but you give them a single conversion script that goes from a FHIR document to CDA, and then bam, you end up with all the CDA documents that you need to comply with today's regulations. They're a lot more consistent, and the developers don't waste their time learning what I won't call it an obsolete standard, which may be in a few years. It's still heavily in use, but certainly the momentum is moving towards FHIR and away from CDA at this point. So there's lots of ways you can convert from C-CDA to FHIR and FHIR to CDA today. Most of them are either open source or some proprietary solutions that are out there. There is, however, just basically starting in May, we started a C-CDA to FHIR mapping project in HL7. So its goal is to create definitive mappings, HL7 sanctioned mappings between CDA and FHIR using FHIR mapping language. So that's using things like the structure map resource and such. So this just got kickstarted. We had a first demonstration of some very primitive transformations at the May working group meeting. So this is not expected to be complete until September 2019, at least according to the current project scope statement. So I wouldn't say it's something that's easy to use right away, right now, but it's certainly where we're headed. But for now, if you do want to use it, again, there's a bunch of solutions out there. The one that I've worked on is it's for basically converting pharmacist care plans. That was the use case for it, but it actually handles a lot more as well. So that's available up at GitHub. That one is using XSLT again, but moving forward, we'll be going to the FHIR mapping language that I mentioned previously. So for managing documents, FHIR documents basically are persistent objects, as I said at the start. So you need to store them somewhere. The easiest place to put them is simply at a FHIR server. So FHIR documents are bundle resources, so you could store them at the bundle endpoint if you want to operate on them using all the search parameters and such for bundle. If you want to treat them as just sort of immutable persistent objects, though, you can also post them to the binary endpoint. And when you do that, you can actually put your FHIR documents there. You can put your old CDA documents there. You can put raw PDFs. pretty much anything you can put at the binary endpoint. It is possible to also use document management systems. If you want to take a FHIR document and store it in a document management system, you can. Clinical data repositories as well. I've seen people just build their own databases from scratch and store them, or just store them in raw file systems. So none of those are prohibited, but again, since they're persistent objects, you should put them somewhere. So for validating FHIR documents, the easiest thing is just grab the FHIR validation tools that are provided with the spec. So there are XML schema and schematron files if you like doing them sort of the old way. If you're familiar with doing that with CDA, you've got the option to do those with FHIR as well. They're not as complete, though, as the actual FHIR validator. So the FHIR validator is a Java tool that you can use, download, and run, and that will check all the bells and whistles of the FHIR spec. You can also do profile validation against that as well. So that's the recommended way to validate a FHIR documents. Again, the schemas and schematron will just sort of get you the basics. Also, FHIR servers do validation. So if you post a FHIR document, for instance, to the bundle endpoint, and then you run the validate operation, and you've got things like profile meta tags in there, it will check them and make sure that you've actually followed all the rules. So if you're using a FHIR server to generate your documents, that's probably the way to go. So future work. One thing that we didn't cover in the C-CDA on FHIR spec, aside from the other 20% of stuff that wasn't in US core, were unstructured documents. In other words, things like how do you represent a scanned PDF file. For those, we purposely decided not to do that because we were discussing whether we should make a composition profile or a profile in the document reference resource for that. Since then, the US core project has actually picked that up, and they've created a US core document reference profile on their most recent ballot. So basically, we're just going to adopt that and use it. And there have been several Connectathon tracks now that talk about doing clinical notes that use the document reference profile for just that purpose. There are some entry profiles like Emma was mentioning that are not covered by US core. So we expect that C-CDA to FHIR mapping project to pick those up and start addressing them. Again, by the end of the project scope, by 2019, September, we hope to have mappings for everything that's at least, really clinically relevant. We understand there's probably a few profiles out there in C-CDA that no one's ever implemented and probably never will. So we may not get to all those, but the goal is that anything that's actually been in use, we do want to have profiles made for them that ideally map what was done in CDA, at least in terms of terminology and cardinality. Other implementation guides we'll create as demand is driven. I mentioned that pharmacist care plan project that created actually a dual CDA and FHIR implementation guides simultaneously and made sure that they were in sync with each other. And we created those transforms to go along with that. There are also other implementation guides out there that mirror what was done in CDA, such as for electronic case reporting or healthcare-associated infection reports as well. So there's a lot of momentum around creating FHIR implementation guides for things that were previously CDA use cases. And again, that CDA to FHIR mapping project. So in general, question you want to ask yourself if you're moving to FHIR documents is, is your roadmap, on FHIR? In my opinion, FHIR basically evaporates HL7 version 3 messaging. I know there are some folks in Europe who use it. You're wrong. In the US, it never really took off, and I think as we move towards FHIR, there's less and less a need for HL7 version 3 messaging, especially if you're bringing up new implementations. Obviously, if you have something existing that's working, don't just throw it out. And that's going to be the use case for HL7 version 2 as well. HL7 version 2 interfaces are everywhere in the hospital. They're not going away anytime soon. In fact, after the nuclear war, when everything is gone except for cockroaches, the only other thing left will be HL7 version 2 interfaces. So they're not going to go away. But for CDA, I like to think that FHIR retains the core document concepts that were found in CDA and improves on text and data management, and you have a unified model and syntax with messages and APIs. So CC on FHIR, again, it's a standard for trial use, just came out in April. It's not, everything, not a guaranteed solution for everything that you're doing with CDA today, but it's ready for use. And we are using it in production in a variety of systems, especially, like I said, sending these pharmacist care plans around. We've sent tens of thousands of those in production use, and they're actually working great. But definitely more testing and more implementation is needed. So folks who are interested in doing a document-based exercise, there is a documents table like far in the back of the lunchroom there where no one can see it. But I'll be there, when I can, certainly at lunch times and such. And basically, folks who just want to walk through some of the Connectathon tracks. We've run probably about 7 different FHIR document tracks at various HL7 Connectathons now. So I'd be glad to help people walk through those scenarios and learn how to build documents if you wish. And basically, resources, FHIR spec, I think everyone knows where it is. There is a white paper that's co-authored with myself, Leo Alschuler, and Graham Grieve on sort of a position statement on FHIR documents, and it became actually the basis for many of the changes that happened in FHIR DSTU2 and STU3 to make FHIR documents really workable. And myself, I'm updated continuously, rebooted occasionally, usually around happy hour. And take questions in just a second. I wanted to very quickly, though, I mentioned CDA to FHIR conversion. I actually wanted to just quickly demonstrate that. So since I've got a couple minutes. So here's an example of a CDA document. So this is a HL7 version 3 based XML, and you can sort of scroll down and see, it's got a patient there, record target. You can see their patient's name, birth date. You can also, maybe let's see, 70618. Yeah, everyone's got the RX norm code for penicillin memorized, right? So you can scroll down and see their allergy information present. So this is all HL7 version 3 CDA XML. When I run this XSLT transform and convert it into a FHIR document now, I've actually got a bundle resource with a composition on it. You can scroll down. It's got narrative-based markup in XHTML. I can see the document type, which is the exact same as it was in CDA. And I can also look down and, for instance, find the subject. Apologies here. And if you follow these references, you can actually see that they point to, in this case, a patient resource that has all that patient information present. Their name, date of birth, gender, everything that was present in the CDA document is converted over. And likewise, that same allergy that's present, that was present in the CDA is now converted into an allergy intolerance resource. So you've got all that coded information now present. And it's safe to process outside of the document context, since we actually preserve context. We preserve who the patient is, who asserted to this information. All that type of stuff is brought over. So this can now actually, if you want to, you can post it to the transaction endpoint of a FHIR server and break it apart and use its component pieces. Yeah. There is as well. So if I were to take a FHIR document bundle in this case, so this is a annotated sample of a pharmacist care plan. Let me just go back up to the top, and I can convert this and make a compliant CDA document out of it as well. Okay, so this now has, instead of a patient resource, we have a record target with all this information in it. Now this was designed for the pharmacist care plan use case. So everything that's needed in a pharmacy care plan, like medications, conditions, allergies, they're all in here. Doesn't cover all of C-CD, for instance, but I've did a lot of work with it approaching HIMSS to actually cover quite a bit. So it's useful, quite useful, I would say. I know you had a question there, so go ahead. Yeah. So there's a link to those transforms. Should be up here in the presentation. Where did I put that? Right. You want the link to the transforms, or? Right. So you can download those here. So github.com/lantanagroup/phcp public transforms. If you want to grab those. It's basically XSLT with a Java driver around it. And like I said, it's useful until such time as that CDA to FHIR mapping project really takes off. So right now this has quite a bit more coverage, but over time we expect that to change. Yes, if you want. How many EHRs have implemented that? I don't know. I'd have to ask EHR vendors. I don't know of anyone that's implemented that conversion capability. But again, that's another reason why we created the transform, so folks who want to start using FHIR documents can just convert back to CDA and send those, and folks can process them as normal. Yes? Well, again, there's certainly the Argonaut project and all that are working on creating APIs for them. The question on when they're going to bring up FHIR documents, it's a little early. Again, this spec just came out in April, and their time frame is usually a year or more in the future. So, certainly I would say start applying pressure if it's something you're interested in. Yes, time? All right. Well, thank you all, and hope you have a good day.